Alright, we're going to call this today more triangle information. More triangle information, and we're going to get the theorem on the top of page 345 in your notes. And it says that the measure of an exterior angle of a triangle is greater than either of its remote interior angles. So if we had this diagram, and we made this angle 1, it's an exterior angle. And then inside this triangle we got angle 2, angle 3, and angle 4. The measure of an exterior angle of a triangle is greater than either of its remote interior angles. Alright, in this case, angle 1 is going to be greater than angle 2, and it's going to be greater than angle 3. So the measure of angle 1 is greater than the measure of angle 2 and the measure of angle 3. Because earlier in the year we said that the measure of angle 1 is equal to the sum of its remote interior angles. So angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So in that case, it's got to be greater than both of them. Does everybody see that? Now, just watch this, please. If I erase that angle and I move it, I'm just going to move it over a little bit. I'm going to put a line right here now. And I'm going to call this angle 5. Angle 1 hasn't changed, has it? Alright, isn't it still an exterior angle? And let me call this angle 6. So angle 1, it was greater than angle 2 when angle 2 was the only angle up there, wasn't it? Don't angle 2 and 5 combined form the old angle 2? So isn't angle 1 greater than 2 and 5? Okay? It's still greater than 3, isn't it? And now, isn't 6 a remote interior angle for angle 1? So angle 1 in this case now is bigger than 5. It's bigger than 6, it's bigger than 3, and it's bigger than 2, isn't it? So keep that in mind when you're doing your practice today, because that's what they're doing, is they're taking a very basic looking problem and then they're just splitting angles up and adding numbers in there. But don't forget or don't lose sight of the fact that this is still an exterior angle and it's still greater than this one. Let's make this one green. It's still greater than this one, no matter how many angles are in here, and it's greater than this one, no matter how many angles are there. Okay? That makes sense to everybody? Very good. Let's turn the page then and look at the top of page 346. And we're going to say that in all triangles, the longest side is opposite the largest angle and the smallest side, let's say shortest side, is opposite the smallest angle. In all triangles, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. So let's take another triangle. We're going to label this triangle ABC. And the angles in this triangle are going to be 60, 80, and 40. And we are going to order the sides from smallest, and let's check that. Let's call it shortest, just to stay consistent with the definition. To longest. The shortest side of this triangle, the shortest side of a triangle, is opposite the smallest angle. So isn't the 40 is the smallest angle? So wouldn't side BC be the shortest side? The longest side is opposite the largest angle. So what's going to be the longest side of this triangle? AC. So side AB is the medium length side if you're going small, medium, large. Alright, because it is opposite this 60-degree angle. Everybody understand that? Alright, they may give you the same question and leave out some angle measures. If you get X, Y, and Z, and you get a 30 and a 100, and again you're asked to order the sides. And you're going from, let's go from large to small this time. Alright, you got a triangle, two of the sides sum 130. So what's the third, or two of the angles sum 130? What's your third angle going to be? It'll be 50 degrees because your three angles have to sum 180. So what's the longest side of this triangle going to be? We're going from longest to shortest. Good. Y to Z is the longest. What's the second longest? Y to X. And what's the shortest? X to Z. Good. Does everybody see that? Now just watch for a second. You don't have to write this down. If you got a picture like this, and maybe the triangle is MNO, and you got the same question to order the sides, but maybe this is 3x plus 5 and this angle is 2x minus 10. You still have to find all the angle measures, don't you, so that you can order the sides. But what does the 3x plus 5 and the 2x plus 10 have to add up to in this case? The two acute angles in a right triangle have to sum 90 degrees. So you would combine those and set them equal to 90 and solve for x. And then you could substitute to find angles M and O. And then you could order the sides. Okay? Alright, so the questions will start out being really easy. They'll give you all the angles, and then they'll give you two of the angles, and then they'll give you one of the angles and some expressions, and you're going to have to write an equation, solve, substitute, and then order the sides. Okay? Alright, next part of your assignment today. So that theorem talked about longest side opposite largest angle. So now we're going to say that in all triangles, the largest angle is opposite the longest side. And the smallest angle is opposite the shortest side. So now let's say you've got a triangle again. Aren't my lines much straighter today? I went home yesterday and practiced my line drawing. I think they've really improved. So I did that for all of you because you're my favorite class. I just thought straighter lines looked a little more professional, and I wanted to be professional for you. You're welcome. Okay, so let's say you get triangle MNO that has really straight sides. And M to N is 10. N to O is 12. And O to M is 19. And now you're asked to order the angles. Let's go small to large. Alright, smallest to largest. So now you're going to look at the sides, and you're going to look opposite the side to find the smallest angle, right? So if 10 is your shortest side, what's the angle opposite the 10? O. So O would be your smallest angle. Your next smallest side is the 12, and the angle that's opposite the 12 is M. And your longest side is going, or I'm sorry, your largest angle is going to be opposite the longest side. So there's your longest side. Opposite of that is N. Anybody have a problem with that? Okay. Any questions on any of that? So based on some given information today, you're going to be able to determine the order of side lengths based on angle measures, and vice versa. You'll be able to determine angle measures based on side lengths. What if you were given, what if you were given a right triangle? And your sides were 6, 20, and we'll call this triangle MNO again. Could you order the angle measures? Could you find side NO using the Pythagorean theorem? Yeah, you could. So you could find sine NO using the Pythagorean theorem, because NO squared plus 6 squared would equal your 20 squared, wouldn't it? And after you found that third side, then you could order the angles, couldn't you? Alright, so you'll see problems like that. The problems are going to start off real easy, where they give you almost all the information, and then they're going to work towards, they're going to give you less and less information, and you have to go solve the problem to get the information. Got it? Alright, your assignment for today is on page 348. Eight to 19. (22, 23). (39 and 40). Please check your odd answers.